So, what is actually differentiation? Well, differentiation is nothing but the ratio of any quantity which is changing over another quantity which is also changing, right? And what is the simple definition I have told you? Which literally means that when a quantity is changing, for example, the number of cases of COVID 19. So let's take this example. So in India, each day some new number of cases are happening, right? So the number of cases per day, you can state this as an example of differentiation, and you can see this as on the x-axis we have time. So from March up until August we have the graph, and on the x-axis what we have is the change in number of cases, right? So this is differentiation. So in daily life we can say that there are different numerous examples, like what is the patient's recovery rate as opposed to the doses of the medication given to them, or for example we can say that what is the rate of change of temperature according to time. So this is an very fruitful example which we can understand and which we can improve. For example, if we want to know if there is going to be rain tomorrow, then what we are going to see is what is the change in temperature, what is the change in humidity, and we can predict that at particular instance of time we are going to have rain at that particular time. So, differentiation we have stated as rate of change of a varying quantity to another quantity, but we can't state this in the purpose of mathematics. So, for mathematics, what we do is we have some kind of notations. So, let's say we have a function which is f of x equals to y, right? And let's take this function as to be the original function, right? Original function. So when you differentiate this function, what we get is we get f dash of x, and which we also called as y dash. But what is this in real sense? For example, if we take y equals to x square, then what is actually differentiation? Well, it is nothing but the change in y divided by the change in x. So this is what we can say is when you find y dash, you can say this as we are differentiating with respect to x, isn't it? Because when the x value will get changed, automatically the y value is changing. So when you have a slope, which is the differentiation, you will have a particular type of function which is the derivative of it. So the process of getting from the original function to the first derivative, like this is the first derivative, isn't it? So the process of getting from the original function, which is this function, going from this function to this function, this process is called as differentiation. So in mathematics, we need to know which process we are going to do in order to find a particular function. So in this segment, we are going to see the relationship between what is the continuity and differentiability of a function. For example, we have taken this function which is y equals to x square. So this graph is particularly y equals to x square, and we have the function, and we know that limit h tends to 0, f of x plus h minus f of x upon h. If we have this value as f dash of at particular point c, then we can say that this function is differentiable. So let's check if this point is differentiable. So if we put f of x as x square, we know that limit h tends to 0 by first principle, we have x square plus 2hx plus h square minus f of x is x square, everything divided by h, and we know this by definition. And then we have here x square and x square gets cancelled, and we have h common, so limit h tends to 0, we have h in common, so we have 2x plus h in the numerator, everything divided by h at the denominator, so this h gets cancelled and we have 2x plus h, and limit h tends to 0, and this function will be 2x. So we know that y dash, or the derivative of x square, is 2x. So I'll just rub this off in order to make you understand what is the exact meaning. So now we know that if the function is y equals to x square, then dy upon dx, which is also can be stated as f dash of x, is equals to 2x. So we know that at any particular point, at point C, no matter what the point is, this function is going to be differentiable. But since we know that the left hand derivative, which is limit x tends to 0 negative f of x, which is equals to f of 0 limit x tends to right hand limit of f of x, this satisfies for x square, we can say that this function, which is differentiable, is also continuous. Well, this is true for each and every example. You can check it by yourself. But what is the other way around? The other way around is saying that all the continuous functions, just like x square, are differentiable. But in fact, we can prove this in very few seconds that this is not true. So for this purpose, we'll take another graph. So we'll take another graph of this. So this graph is y equals to mod of x. So each and every negative value of x gets converted to positive value. So if you drag this line over on the negative side, you will have the exact mirror image of this graph. So what we can say this as, at this particular point 0, so we have this as at point 0, we can say that this particular function is not continuous. Well, how? We can say that there is no actual difference in change in x-axis. So when you know that dy upon dx, or rather differentiation, is nothing but change in y upon change in x, so in this case we won't have any change in x at x equals to 0. So at point x equals to 0, so let's take that point as a, which is 0, 0. So if you take that point a, which is 0, 0, you can say that there is no actual change in the x-axis, and you cannot define such examples. You can't define. So in this particular example, we can directly reflect that since we don't have any kind of left hand limit or right hand limit, we know that this function is continuous throughout, but we cannot say that this function is differentiable. So at this instance, we know that y equals to mod of x, this function is continuous throughout from minus infinity till plus infinity, but this function is not differentiable. So what we have seen today is, so I'll just explain again in short time. What we have seen is differentiation is nothing but the change in variable quantity 1 divided by change in variable quantity 2. We can say this as also as the ratio. So ratio. And for this general understanding purpose, we have taken example of COVID-19 cases in India, so which is a very hot topic, and we have seen the notation. So in the next video, what we are going to see? So in the next video, we are going to see the real meaning or the real understanding of differentiation of composite functions. Then we can see logarithms, like differentiation of logarithms. Then we have inverse functions, and so on and so forth, which is defined for the 12th standard syllabus. The actual definition part is completed over here. The mathematical part or the formulas and other stuff will be covered in the next coming videos from tomorrow. Thanks for watching.